Hello guys, welcome to another tutorial on CHM101, and this time around we're explaining the concept of limiting reactants. Actually, in the real world, what we portray on paper as a reaction is actually not the way it looks like in the real world. In the real world, something will always limit the other from reacting. That's why if you carry out I don't know, some of you might be used to caustic soda. When some of you make soap and you're used to caustic soda, if you put caustic soda in water, from the first time it reacts loudly, and after some time it dies down, and something has limited the other from moving on. So how do you get which reactants limit the other in a reaction? It is actually simple. Now this is a question. You have 2 grams of sodium hydroxide, you have 3 grams of HCl. They are reacting with themselves. You pour them inside one cup and they've reacted, and one of them will limit the other from moving on. How do you get it? Firstly, calculate your number of moles. Remember from our previous video, number of moles, that's calculating number of moles, that's reacting mass all over molar mass. So reacting mass, that will be reacting mass of sodium hydroxide is 2 all over the molar mass is 40. I believe you remember that. So calculating the number of mole, that will be reacting mass all over molar mass, and for sodium hydroxide is 2 over 40, and for hydrochloric acid is 3 over 36.5. Now calculating this should give me 0.05 mole. Calculating this should give me 0.08 mole. Now don't quickly pick this one as the limiting reactant because this one is smaller. No, it doesn't always work that way. You have to first work out the stoichiometry of reaction before you can tell. Sometimes it does work this way, but it doesn't always work that way. You cannot just tell from seeing the number of moles. You're supposed to work it out. Okay, let's work out the stoichiometry of reaction so that we know the actual number of moles of sodium hydroxide that will react with the actual number of moles of hydrochloric acid here. So remember from what we've done, let's first go to the standard. Since we are working in terms of moles here, we will then say, remember that this is 1 and this is 1. So we can then say 1 mole of sodium hydroxide we always react with 1 mole of HCl. So 0.05 mole of sodium hydroxide should give how many mole of HCl? So that becomes at the end of the day it becomes 0.05 mole of HCl. So I just pick sodium. You can decide to pick hydrochloric acid and work with it. So I just picked sodium, and I realized that if 0.05 moles of sodium hydroxide should react with HCl, it must react with 0.05 moles of HCl. Now in the real sense we have 0.08 moles of HCl. So if 0.05 mole of sodium hydroxide reacts with 0.05 mole of HCl, then we still have 0.03 left. So this one is still left in the reaction, whereas this one is already used up. So this is the limiting reactant, sodium hydroxide. And you might be wondering, what if you picked what if you picked hydrochloric acid instead of sodium hydroxide here in the first place? Yeah, let's try it out. So 1 mole of sodium hydroxide reacts with 1 mole of HCl. Now how many mole of sodium hydroxide will react with 0.048 mole of sodium of hydrochloric acid? So we can see that it is 0.08 mole of sodium hydroxide, but we only have 0.05 mole. We still need 0.03 mole to complete this. So therefore we can see that this one we need 0.08 mole of sodium hydroxide, but we only have 0.05 mole. So this sodium hydroxide will limit the reaction once it gets to 0.05 mole. So I believe we understand that. So That is the concept of limiting reactants. You must first know the number of mole for each of the reactants in the question, then work out their stoichiometry of reaction and know which one is limiting the other from proceeding. It's as simple as that. Thank you. I remain Olasende Fit. Bye.